Welcome to the how-to video for enthalpies of a reaction. When we talk about the enthalpies of a reaction, we're really talking about the change in the enthalpy of the reaction, or delta H. In this case, we really can think of delta H as really just equal to the enthalpy of the products minus enthalpy of the reactants. And for an exothermic reaction, delta H is going to be less than 0. And in that case, that really means that the enthalpy of the reactants is going to be much greater than the enthalpy of the products, thus leading to enthalpy being released in that reaction. One example of this is when we look at hydrogen gas plus oxygen gas to produce water vapor. And in this, we would notice that this is a very explosive reaction where we're actually giving off energy, and we're giving off that energy in form of enthalpy. So when we think about enthalpy, there's really three key things that we have to remember. The first is that enthalpy is an extensive property. Extensive property really just means that it depends on how much. And we can see that for this reaction, as methane gas is converted to, or reacts with oxygen gas to produce carbon dioxide and water, we form an enthalpy change in the enthalpy of the reaction of minus 890 kilojoules. That means we're releasing minus 890 kilojoules of heat. So this is given for a single mole of methane gas being combusted. But what if we had 2 moles of CH4 instead of 1 mole? What this means is that enthalpy is an extensive property, and so for 1 mole, this is minus 890 kilojoules per mole combusted, we now have 2 moles. And so it would be 2 times minus 890, and so we end up with minus 1,780 kilojoules for 2 moles, and so forth. The second important rule is understanding that when we talk about the enthalpy of a reaction, that in the forward direction, it's going to be equal in size, but opposite in sign to delta H for the reverse reaction. All this really means is if we write the above reaction backwards, where we have carbon dioxide gas plus 2 H2O liquid, is producing 1 mole of CH4 gas and 2 oxygen gas molecules. If we were looking for the delta H of this reaction, well, the fact that we've just switched the order of the reaction, we flipped it over, means that now this is going to be positive 890 kilojoules. Third, we have to understand that the delta H for a reaction depends on the state of the products and the state of the reactants. So if we look back up at the top reaction, we could think about it as what instead of producing water as a liquid, we actually just had water as a gas. And in that case, when we really think about that, we would find out that the delta H for that reaction is minus 802 kilojoules. Because now we're producing water as a gas, we're not producing water as a liquid, and so the delta H for that reaction is different. That completes the how-to on the enthalpy of a reaction.